Good morning all. My name is Santosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about program control. So, a program control instructions are the machine code that are used by machine or in assembly language by user to command the processor act accordingly. These instructions are of various types. These are used in assembly language by user also. But in level language, user code is translated into machine code, and thus instructions are passed to the instruct the processor do the task. There are so many types of program control instructions are there. So first I have to go for high level language. So high level language means I am going for Java, Python, any of them. So this high level language definitely we are converting to the machine language. Why? Because machine language is a computer understanding language. So this is the computer understanding language. So there are three types of languages are there. First one, high level language, low level language, and machine level language. So high level also definitely we have to convert to the machine language. If you have to take the low level language also, we have to convert to the machine language also. So machine language is nothing but a computer understanding language. So here the program control is a machine code that are used by machine or assembly language. So this low level language we are calling as a assembly language. So machine language is a binary code. Any of the high level language or low level language, definitely we have to convert to machine level language. So machine level language is nothing but a binary code in the form of 10, 10, 10 like this. So any of the code we have to convert to the binary code. We have to convert to the binary. So if my program is in the form of Python or my program is in the assembly language means microprocessor using programs. So high level or low level, definitely we have to convert to the machine language. So these are command processor accordingly, and these instructions are of various types. So what are the instructions means? Suppose I am taking addition of two numbers in Python. So how many lines are there? Those lines I am calling as instructions. Suppose I am taking addition of two numbers in assembly language. Move ax comma bx, add ax comma bx into 03. So it is a program. What is a program means? Addition of two numbers. So assembly language means it is a assembly language program. So this assembly language I am converting to the machine language. So here move command is there, add is there, int is there. So these are called instructions. So these instructions are converting to the machine language. So our assembly language is converting to the machine language. But in level language, user code is translated into machine code, and thus instructions are passed to instruct the processor to do the task. So there are so many types of program control instructions are there. Data transfer and manipulation instructions specify the conditions for data processing operations, whereas the program control instructions specify the conditions that can alter the content of the program. So any of the high level language we are converting to the machine language, that is the binary form, binary coded form. The data transfer of manipulation instructions, any of the data manipulation instructions specify the conditions for data processing operations, whereas the program control instructions specify the conditions that can alter the content of the program counter. So here some program control instructions are there: branch, br, jump, jmp, and skip, skp, call function kcall, and return ret, and compare cmp, test by adding that is the tst. So any of the program control instructions, these are instructions as previously I told: add, move, int. So these are called instructions. So what is the abbreviations of these instructions? That is the mnemonic code. So if I am taking branch means br, jump means we are jumping from one to another, jmp, skip we have to skip the register or register value, skp, call function, return function, compare, CMP, and testing. So these are the some examples of program control instructions with abbreviations. Compare instruction. Compare instruction is specifically provided which is similar to a subtract instruction, except the result is not stored anywhere but flags are set according to the result. Example, CMP R1, R2. Here R1 and R2 are the two registers which have some values are there. Maybe R1 equal to 1011 like this 1011. So compare instructions means we are comparing the two registers or two register values. So definitely we need minimum two registers to compare. So which is similar to a subtract instruction, except the result is not stored anywhere but flags are set according to the result. Compare R1 equal to 5, R2 equal to 4. How can you compare means I am taking subtract instruction to compare. So 5 is greater or 4 is greater. How can we know? So we are comparing with subtraction. So like this, 5 greater than 4. That means R1 is greater than R2. R1 is less than R2 like this. So we are comparing with two register values with specified values. And unconditional branch instructions means there is no condition to define the branch. It causes an unconditional change of execution sequence to a new location. Jump L2 means the line L2 values are jumping. Move R3, R1. So R1 values are moving to the R3, go to L2. So is it unconditional? Yes. Just I am defining one line jump L2 and move R3, R1. R1 values are moving to the R3. Go to L2. After moving this, it is going to the L2. So it is a unconditional branch. There is no condition to moving from one register values to the another value, on one location to the another location. That is a unconditional. Conditional branch instructions. A conditional branch instruction is used to examine the values stored in the condition code register to determine whether the specific condition exists and to branch its codes. So, assembly code BE R1, R2, L1. Compiler allocates R1 for X and R2 for Y. High level code if X double equal to Y, go to L1. So conditional means we have to give some conditional value. Suppose previously we discussed here move R3, R1. That means R1 register values are moving to the R3. Is it any condition? No. When the line is L2, then only it will be moved. But here, if X double equal to Y means if X equal to Y, then only it is go to L1. Is there a condition? As we have the condition, that is a if condition. If X double equal to Y, then go to L1. Otherwise, it will not go to L1 like this. So R1, R2 that is belongs to L1. Allocates the R1 for X and R2 for Y. R1 is equal to X, R2 equal to Y. So we are allocated these values. Allocated these R1 equal to X, R2 equal to Y. When high level, if X double equal to Y, go to if X equal to Y. If X equal to Y, then go to L1. When it is go to L1, when X double equal to Y. If not satisfied this condition, it can't go to L1. So that is the conditional branch. Subroutines. A subroutines is a program fragment that lives in user space, performs a well-defined task. It is invoked by another user program and returns control to the calling program when finished. Call and return. Example, call and return. Subroutines are there. So, call function and return function. So, we have to call from one register to another. There is one register value is there that is stored in another memory. So, that memory values are calling now, and all otherwise these register values are returning to that memory. So both are calling or returning. Calling means we are calling that function. Returning means we are replacing that one. So a subroutine is a program fragment that lives in user space, performs a well-defined task. It is invoked by another user program and returns control to the calling program when finished. So call R1, return R2. like this. So we are calling R1. Maybe it is in a memory with in specific address. In the specific address, maybe the R1 is there. Return R2 means it is a memory with specific address. So like this. So we are calling R1 function or call X or it return like this. Halting instruction, we have to wait until the output will be get, or otherwise we have to waiting for another input. So NOP instruction, NOP is no operation. It causes no change in the processor state other than an advancement of the program counter, and it can be used to synchronize timing. Halt, it brings the processor to an orderly halt, remaining in an idle state until restarted by interrupt, trace, reset, or external action. So NOPs means no operation. No operation is going on. That is called the NOP instruction. So it causes no change in the processor state other than an advancement of the program counter, and it can be used to synchronize timing. Halt, we have to wait some time. It brings the processor to an orderly halt, remaining in an idle state until restarted by interrupt, trace, reset, or external action. So suppose I given one input R1, so it is state until interrupt. When I'm going for the interrupt means multiple tasks are going on. Okay, so interrupt 03. Where interrupt means multitasking. So multiple operations or multi op-amps are going on. So we have to halt for some time to get the output. We have to wait some time for another output or another input. So that is called, it brings the processor to an orderly halt, remaining in an idle state until restarted by interrupt, trace, reset, or external action. So interrupt instructions. Interrupt means when we are getting multiple operations are going on, then we need a interrupt. Interrupt is a mechanism by which an input output or an instruction can suspend the normal execution of processor and get itself serviced. Reset, trap, INTR. These are the interrupt instructions. Reset. It reset the processor. This may include any or all setting registers to an initial value or setting program counter to standard starting location. Trap, it is non-maskable edge and level triggered interrupt. Trap has the highest priority and vectored interrupt. INTR, it is level triggered and maskable interrupt. It has the lowest priority and it can be disabled by resetting the processor. So interrupt means when we are multiple inputs and multiple outputs are there, then we have to go for the interrupt is enabled, that is INT equal to 1. So it is a mechanism by input output operations of instruction can be suspended in normal execution of processor and get it itself serviced. Normal actions will be cancelled. So priority will become when the interrupt is came. Interrupt means priority will be accept. So the priority will become when interrupt is came, priority will become. So this interrupt instructions, first one reset. The reset the processor. This may include any or all setting registers to an initial value or setting program counter to standard starting location. That is a reset. Trap, it is non-maskable edge and level triggered interrupt. Trap has the highest priority and vector interrupt. Suppose I am going for there are so many interrupts are there. So what is the highest priority of the interrupt? Suppose I have INT0, INT1, INT2, like this, INT3. So highest priority is the trap, and INTR is a level triggered and maskable interrupt. It has the lowest priority. Lowest priority. So reset is the processor. This may include any or all setting registers to an initial value or setting program counter to standard location. So it is a reset. Reset means the already output is came. We have to go for the next input. So we have to freshly we can start that one. Okay, we have to start refreshing that one. That is a reset. Trap means non-maskable edge at the level to trigger interrupt, and the highest priority of the interrupt is called a trap. And INTR interrupt, it is a level triggered maskable interrupt, and it is the lowest priority. It is a program control instructions. Program control instructions means PC. So we have to go for PC plus one like this. So PC and plus one is the inline sequencing. Next instruction is fetched from the next adjacent location in the memory. Address for mother source, current instructions, stack, etc. Branch, conditional, branch subroutine, etc. are the program control instructions. These are the some program control instructions. That is a branch BR, jump JMP, skip SKP, call CALL, return RTR, and compare CMP, and test by AND gate. So CMP and TST instructions do not retain the results of the operations and respectively. They only set or clear certain flags. So it is a status flag circuit, 8-bit of ALU, arithmetic logic unit. So 8, B8, 8 lines are there. So check for 0 output, C7, C8, and F is the flag. So here VZSC, we are going for the status flag. What is the status of the register? And these are the references. So in the program control, the machine code that are used by machine or in the assembly language by using the command processor. And according to that, these instructions are of various types of instructions are there, and these are used by assembly language by user also. So high level language, assembly language, also called low level language, and third one is the high level, low level, and machine language. So high level languages are the Java, C, Python, like this. Assembly language of the machine language is the binary code. So any of the high level language is converting to the machine, and assembly language is converting to the machine language. So these are the converting to the high level to machine language or low level to machine language or assembly language to the low machine language. So the data transfer and manipulation instructions specify the conditions for data processing operations, whereas the program control instruction PC, program control instruction PC tends to PC plus one, like, and these are the specifying the conditions that can alter the content of the program counter. So these are the program control instructions with a mnemonic means specific codes. So branch, BR, jump, JMP, skip, SKP, call, return, compare, and test. So compare instructions. Compare instruction is specifically provided, which is similar to a subtract instruction, except the result is not stored anywhere, but flags are set to according to that result. So I'm comparing the two functions CMP R1 comma R2, and unconditional branch means jump L2, move R3 comma R2, go to L2. So if I'm comparing the two registers, so we need, so compares are the arithmetic operations. with specific registers. So this I'm comparing with R1 comma R2. So I'm comparing R1 and R2, which one is the largest value or which one is the smallest value or which are the equivalent. And unconditional branch instruction means I don't have any condition to go or jump or shift from one to another like this. So jump L2, that is line L2, when move R3 comma R1. So the R1 values are moving to the R3, go to L2. Is it any unconditional instruction? If it is the conditional instruction, then we have to keep a condition to moving the values or moving the register. A conditional branch instruction is used to examine the values stored in condition code register to determine whether the specific condition exists and to branch if it is just assembly code. Already told assembly code is a low level language. BE R1 comma R2 comma L1 means L1 equal to line 1 and R1 R2 are the two defined functions, and we are compiling allocates R1 for X and R2 for Y. So when I'm compiling these two registers, definitely R1 equal to X it will take and R2 equal to Y. So it will go to L1. When it is go to L1 means if X double equal to Y, then only it will go to line 1. Otherwise it will not go to line 1. So it is a conditional branch. Subroutines is a program fragment that lives in user space, performs a well-defined task, and it is invoked in user program to return control and program when it is finished. Call and return functions are the subroutines are there. Halting and no program, no operations are there. NOP means no operation is performed. That means no change in the process state other than an advancement of the program counter. It can be used to synchronize. Halt means we have to wait some time until unless the input we are waiting for input or output, and it brings the processor to an orderly halt, remaining in an idle state until restarted by interrupt, trace, reset, or external action. So how many types of interrupt instructions are there? When the priority should become, then we have to go for the interrupt instruction. So interrupt instruction mechanism is which by input output of the instruction can be suspended when the normal execution of the processor engages itself. Normal operations are can be suspended. Only priority should become. So reset means it will include all setting registers to an initial value or setting program counter to standard starting location. So we are reset means we are starting again refreshing the program. Trap means it is a non-maskable edge and it is the highest priority of the interrupt. And in INTR is the low level maskable interrupt and it is the lowest priority can be assigned, and it's a program control instructions PC. If it is PC plus one, it is going to the inline sequencing, and it is address from source to one source to another, current instruction stack, etc. Branch, conditional branch, subroutines, and some program control with mnemonic codes are there. That is a branch BR, jump JMP, skip SKP, call CALL, return, compare, and test by and. So here compare and test instructions do not retain their results of operations and are respectively. They only set or clear certain flags. So these are the data transfer and manipulations are there. So how can we are transferring from data from one form to another form, and how can we manipulate? Means manipulation means when we are assigning the arithmetic operations, we are performing arithmetic operations. That is a manipulation. Data transfer means we are transferring from one register to another. Suppose R1 data is transferring to R2 or R2 data is transferring to the R1. That is a data transfer. And manipulation means we are performing arithmetic operations. Arithmetic operations. When a program is executed, a computer program control instructions allow to make a decision and modify its direction, while collection, replication, and transmission of used datasets from one organization is business until another are done through the data transfer method. The data manipulation instructions are alter the change of the data content. So decrement, we are value decrement, that is a subtracting value. Decrement is nothing but a subtracting. So the arithmetic instructions are we are also called the data manipulations. So load LD, store ST, move MOV, exchange, input, output, push, pop. So these are the data transfer instructions. And data manipulation means when we are performing arithmetic, logical, and shift instructions, that are called data manipulations are there. Okay, so these are the about the program control and its operation and instructions with numeric codes. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.